It is plant disease detection using deep learning. Identifying the disease in plants plays a key role in preventing the losses in yields and quantities of. Basically, farmers detect the disease using their previous knowledge, or they need lot of time and more money to detect the disease. And we are using CNN algorithm for this project. The main aim of our project is to develop a system which automatically detects the disease easily. By this, farmers will not going to spend more time and money for detecting the disease. The scope of our project is to avoiding the crops destruction. Manually to detect the disease in plants takes a lot of time and waste of money. By calling the expertise in detecting the disease in plants, by this process, farmers can lose most of the crops. Our project will help to detect the disease easily without including above process. These are the literature reviews we included, and this is the user interface for project. First, we need to train a model. For training a model, we need to select the different data sets, and for the data sets, we need to add more features. Uh, According to our project, we need to train the model. For that trained model, we need to test whether it is correctly working or not. After testing the model, we need to predict the disease. But the only problem is not interactive because the common people or farmers cannot use it. So to make it interactive, we need to have a front-end design of our model, and it is it be simple and interactive. So we can use the basic HTML and CSS languages. These are the standards and policies, and this is the architecture diagram. First, we need to give an input, and then it will pre-process that input, and then it extract the features, and it will classify whether it is disease, it is affected by disease or not. If it is affected by disease, and it will display the disease name and the medicine which we need to use to cure the disease. And this is the data flow diagram. Uh, we need to collect the data sets and then we pre-process the data. The pre-processed data, we need to make the perfect data sets. And after making the data sets, we need to use learning algorithm, and that we need to train the model and test the model. And testing the model helps to detect the disease or not. Here diagram, sequence diagram, collaboration diagram. These are the different testing methods: functional testing, system testing, integrations testing, unit testing. This is the front end of our project. First, we need to select a file, and then it we need to click on the predict means it will show what disease affected by the plant, and which are the medicines we need to use to cure that disease. And finally, we conclude that uh, our system was very efficient in the way we have the advantage of the identifying the disease for any kind of plants. In the proposed system, we use the convolution neural network to train the data and input images with the average accuracy 95. In the future, we are developing more, more application like apps, and now we are only preparing for one plant, only tomato disease detection, and in future we are preparing more plants to detect the disease.
Hello everyone. Now let's see the implementation of the project. Plant disease detection using deep learning. This is the code for this is the training model. This is the code for it. Let's see how we need to execute this. So first we need to input all the packages and modules. Let me show the requirements of this project actually. These are the requirements. And in this project, we need all these requirements. Okay, this is the code. Let's see how this code is executed. Okay, now I have given the config variable. I have given the function to it, config proto. Config proto is used to configure the session. So we are creating a session here. Okay, now we are importing all the packages like NumPy, Matplot library. Matplot library use it to plot the graphs. Now, initializing the CNN. I have given my model name as classifier and I'm initializing it with sequential function. Sequential function is used to create deep models where an instance of sequential class is created and model layers are created and added to it. In simple words, it is a model that inputs or outputs sequences of data. Now we add the convolution for it. Add function is used to add the elements to the set, and conv2d is the two-dimensional convolutional layer. And max pooling, what does this max pooling do? Max pooling helps in extracting the low level features like edges, points, etc. Now flatten, what does this flatten function do? Flattens the multi-dimensional input tensors into a single dimension. These everything are used in training the model. See, everything I'm doing here is with the adding to the classifier. Classifier is nothing but our model. Now we are using dense function. What is this dense function? Dense function is used to create fully connected layers in which every input depends on every output. Now let's go for the compilation of the CNN. We are using classifier.compile. What is this compile function? Compile function, it configures and makes the model for training and evaluation process. It means if we call this function, it prepares the model with an optimizer, loss and metrics. Now image data generator. Now we are taking the variable train data generation and assigning it with image data generator. Image data generator provides a quick and easy way to augment your images. We are augmenting the images with rescale by giving the values and shear range, zoom range, horizontal flip. Similarly, we give the test gen. Now training set variable, we have given path of the training data. This is my path. For giving this path, we need to use the function flow from directory. It gives the path. Similarly, valid set path. Now let's see how we train the model. I'm using the history word. So in order to plot the graph, I'm using this history keyword, history variable. Classifier is my model, fit generator. Fit generator is used to train the model. Here we give training set, which we have given the variable here training set, and steps per epoch, how many number of steps we need to include for each epoch, and number of epochs. Epochs is like iterations. So I have given 30 epochs. So see, if you run this, we will get the output like this. Epoch 1 by 30, the loss is 0.05, accuracy is 1. Now epoch 2, loss is 0.0153, accuracy is 0.7. Similarly, we get all like how many epochs we give, that many we get epoch number 30. We have given 30 epochs here. As you can see, epochs is equals to 30. So the model is trained with 30 epochs. Now history.history is used to store the keys like loss. What are the values of the loss? All the loss of 30 epochs. See here, if you run this, we will get the keys like this. Given 30 epochs, so for loss, we have 30 key values. 1, 2. If you count this, we will have 30. Similarly, for accuracy, we will have 30 values. If you give epoch as 50, we will get 50 values. Okay. Now let's see how to plot the graph. PLT is I have important matplot library as PLT. I will show that. Import matplot library.pyplot as PLT. Now PLT.plot history.history is this, and I'm plotting the accuracy. And PLT.title, this title name is our choice. I have given model.accuracy, and PLT.ylabel, the thing which you need to be in y-axis, x-label means x-axis. I have given accuracy in y-axis and epoch in x-axis. Legend gives the name and location upper left, and pld.show, it shows the graph. If I run this, I will get graph like this. This is the graph. If you see, the graph is varying from almost, it is like 0.96, 0.9879. It is in the range of 0.95 to 0.99. Now similarly plot the graph for loss. See everything. History loss. Title is model loss. In y-axis I am representing loss, and x-axis epochs. So this is our loss. This is the training of our model. Now let's see the testing of our model. I have already loaded every code. Say this is the testing code. Similarly, we need similar to that of training model. We have to import all the packages and modules. Now I am giving the model.h5 file path. After that, we have to print model loaded successfully. Now I am giving the path of up leaf, just one leaf, so that it gives whether we have to check whether it giving the correct output or not. Now test image is image to array. Test image, convert the image to NP array and normalize it. Now if we use the function expand dimension, it changes the dimension from 3D to 4D, storing the model prediction into the result. And hence if you run this, I'm getting the output like this: model loaded successfully. The disease name is bacteria spot disease. Here we are only dealing with only the tomato data set, so we will get only tomato diseases. Now this is our test, and we have successfully created this. But to make this more interactive, so that every user can use it, we have to make it simple. So for making it simple, we need a front-end application for this. So we have developed a front-end one. That is, we used Flask for it. We have imported the Flask. Similarly, we have imported all the required like NumPy, OS, and TensorFlows. And we have given the file path of model.h5. We loaded the model. Here we created the instance of Flask, render the index.html as it is the front end. We definitely use the HTML, so we have to render it. And after that, using the annotation app.root, we have load this. So if you run this, actually this is getting an error in Jupyter Notebook. It is not running properly, so I'll run it in IDLE. This is my code, same code. We are running this in IDLE. Now I will run this. These are my previous ones. Ignore them. Now we will get new one here. We will get a link, localhost link. If you run this, see, this is the localhost link. We will run this front end only in localhost. Just copy this. And paste in any browser you wish. I'm just pasting it. See, the very basic and simple front end. If we click on browse, then we have to select an image. I will select an image from this data set. So I will select this one. Anyone, we can select anyone. Now predict. This is showing the correct output: tomato, early blight disease, and in addition to it, we are showing the treatment, like tomatoes that have early blight require immediate attention before the disease. So let's check this with another image. Now I'll take a healthy image. Let's see. Of course, yes, it is healthy and fresh. There is no disease on the tomato leaf. Let's check with another picture. Okay, I will go with the last one. Tomato yellow leaf curl virus disease, and this is the treatment for it, and this is the execution. We have trained the model, and we have tested it. We have got the output, and we made it very interactive using the Flask. That's it. Thank you.